Hi, my name is Ivan Ryakov, and today we're going to be solving the following problem. Prove for all positive integers n that 9 to the n minus 1 is divisible by 8. For brevity throughout the rest of this video, I will use the following notation, where on the right-hand side of this bar, I say the right-hand number is divisible by the left-hand number, or I will say that the left-hand number divides the right-hand number. So in this example, I would say 8 divides 9 to the n minus 1, or I would say 9 to the n minus 1 is divisible by 8. Now we will define a predicate for this problem, P of n, which is whether 8 divides 9 to the n minus 1, and we'll restate the problem more formally as proving P of n is true for all positive integers n. We'll start out by getting some intuition for the problem by doing a few examples with small positive integers and seeing whether P of n is true. We'll start with n equals 1, which is testing whether P of 1 is true, which is whether 8 divides 9 to the 1 minus 1, which is whether 8 divides 8. This is true since 8 times 1 equals 8. For n equals 2, we have P of 2, which is whether 8 divides 9 to the 2 minus 1. 9 to the 2 is 81, minus 1 is 80. So we have whether 8 divides 80. This is true since 8 times 10 equals 80. Next we have n equals 3, which is whether P of 3 is true, which is whether 8 divides 9 to the 3 minus 1. 9 to the 3 minus 1 is 728. And if you divide 728 by 8, you get the integer 91, so this is true. For n equals 4, we have P of 4, which is whether 8 divides 9 to the 4 minus 1. 9 to the 4 minus 1 is 6,560, and if we divide that by 8, you get the integer 820. This is true. For n equals 5, we have P of 5, which is whether 8 divides 9 to the 5 minus 1, which is 9 to the 5 minus 1 is 59,048, and if you divide that by 8, you get the integer 7,381, so this is true. And we can continue doing more examples, but these 5 examples should be enough to at least convince ourselves that this pattern appears to hold, but we still need to do a form of proof for all positive integers. So for our formal proof, we'll begin by reminding ourselves that the problem is proving P of n is true for all positive integers n, where P of n is whether 8 divides 9 to the n minus 1. And we'll use weak induction to conduct the proof. Weak induction first starts out with a base case, which involves proving P of 1. P of 1, in our case, is whether 8 divides 9 to the 1 minus 1, which is just whether 8 divides 8. This is true since 8 times 1 equals 8, proving the base case. Now we move on to the inductive step, which involves proving for all positive integers n that P of n implies P of n plus 1. First off, we will start out by assuming our inductive hypothesis, that 8 divides 9 to the n minus 1, aka P of n, for some positive integer n. And we want to prove that 8 divides 9 to the n plus 1, minus 1, aka P of n plus 1. We'll start out by using our inductive hypothesis to conclude that 8k equals 9 to the n minus 1 for some integer k. This is just a definition for what it means for one number to be divisible by another number. Next, we will consider the expression 9 to the n plus 1 minus 1, which is just this expression right here. This expression obviously equals itself. And since negative 1 equals negative 9 plus 8, we can substitute negative 9 plus 8 right here, giving us this. We can put parentheses around these two terms, and then we can factor out a 9 out of these two terms, which inside the parentheses will give us 9 to the n minus 1, like so. At this point, 9 to the n minus 1 equals 8k, so we can substitute 8k into here, which gives us this, getting rid of the parentheses. And then we can factor out an 8 out of these two terms, which gives us this. And at this point, since 9k plus 1 is an integer, since k is an integer, and since we have a factor of 8 right here, we can conclude that 9 to the n plus 1 minus 1 is divisible by 8. This is precisely what we wanted to prove. This is P of n plus 1. Thus, we conclude the inductive step. And since we proved the inductive step, and since we proved the base case, we have concluded our proof by weak induction, and have proved that P of n is true for all positive integers n. So let's recap what we did. First, we defined the problem by defining P of n, which is that 8 divides 9 to the n minus 1, and we defined the problem as proving this for all positive integers n. And then we established intuition by convincing ourselves that P of n appears to be true for certain small integers n by manually checking. And we formally proved that P of n is true for all positive integers n, using weak induction by first proving the base case for n equals 1, and then proving the inductive step where we proved that P of n implies P of n plus 1. Thank you.